Hello everyone and welcome. In this video sponsored by Hankook, we're getting some fascinating insight into what is arguably the most difficult tire to create, and that is the all-terrain tire. So in terms of the various styles of truck and SUV tires, the all-terrain is a bit of a blend between a tire dedicated almost entirely for on-road driving, which we have here, and a tire dedicated almost entirely for off-road driving, which we have here. So why do I say this is the most difficult tire to design? Well, think about what you want in a tire. You want it to be quiet, you want it to be comfortable, you want it to be durable so it doesn't get flats, you want it to wear evenly and last for thousands and thousands and thousands of miles, you want low rolling resistance to maximize fuel economy and efficiency. Okay, then you have the grip factors, so you want it to perform well on dry roads, wet roads, snow, ice, and so far we've basically described the ideal all-weather tire, which is already extraordinarily challenging to make. Basically, do everything in every on-road driving situation really well. But now we're adding on top of that all the off-road requirements. So it needs to perform on dirt, gravel, rocks, sand, mud, basically do everything on every surface possible and do it well. Oh, and again, maintain all of the already mentioned qualities. Of course, durability is a huge challenge when driving on sharp and irregular objects like rocks, but hey, it also has to have really good grip on dry roads. Oh, and snow. Now I must mention, these are not the original equipment tires for this Bronco, but this is a great vehicle to showcase the capability of these tires, and certainly a vehicle that can make the most out of all-terrain tires. And with tires, there's a huge range out there, and that's because specialization is the name of the game. It's much easier to make tires perform well for very specific scenarios, but this tire, the AT2 Extreme, needs to do absolutely everything. It's difficult to overstate how challenging this is because you are forced to make compromises. So let's dive right in, starting with the most important part of any tire, the compound. Now, if you think about it, okay, you've got summer compounds, all-season compounds, winter compounds. As you might suspect, this is most similar to an all-season compound as to accommodate a wide variety of use cases. The difference, though, is that an all-terrain needs greater durability to hold up to off-road scenarios, so the compound in this case is harder. So you have a compound that can handle heavier loads, as these tend to be used on heavier vehicles. Your compound also has a higher tensile strength. Think about the tread blocks gripping a rock. That block is stretching, so it needs to have a good tensile strength. It also needs to have better crack resistance, so if the compound starts to crack, well, now you're introducing all these areas in an off-road scenario for rocks to tear apart the tire. So they're using a harder all-season-like compound, but it still has to have grip in the snow. And as you can see, it has the 3-peak mountain snowflake, meaning it meets the industry testing for snow traction to get this symbol. Okay, so harder compound, and inside with the belts and plies, we also have a harder tire carcass. So you might look at this massive sidewall and think, oh, that's probably great for ride comfort. And there is some truth to this, but in reality this is a much stiffer sidewall versus a typical summer or all-season tire. Part of the reason for these large sidewalls is to reduce the chance of puncture, of course along with a very strong internal structure. This gives you more space between the ground and the wheel, giving you more distance and more time to handle any impacts. So the trend with sports cars is to have very short sidewalls, super low profile tires. But throw this in a high-speed off-road scenario, you hit a rock, and that pinches the tire with the wheel and you blow out the tire. These sidewalls also protect your wheels, since you have all this space that rocks, or let's face it, for some people just curbs, aren't going to be hitting your wheels. In addition, all-terrain tires are often run at much lower pressures, depending on the driving situation. So if you're in sand or mud, drivers might air down their tires to get a bit more grip. Well, you need that strong sidewall so the tire isn't damaged in these scenarios. Okay, so you've got stiffer compound, stiffer carcass, stiffer sidewalls. Now let's get into the tread design. And one of the most distinctive features you might notice is the tread depth. It's deeper than what you'd find on a typical all-season, and of course much deeper than a summer tire. And tread depth may seem insignificant, but it has huge impacts on overall tire performance. So why use a deeper tread? One part is that it means better traction in certain off-road scenarios. Essentially, you have these massive gears that can dig into sand or mud and can help push you through it. And you have better drainage performance for deep water. But another thing you have to keep in mind is these are heavy vehicles. And often these heavy vehicles have a lot of power, so you're putting huge loads and heavy stresses on these tires. That means lots of tire wear. Okay, and as we mentioned, we have a stiffer compound to help deal with this. But what's another way to get a tire to last longer? More tread. You start with more material so you can handle the higher loads for a longer period of time. And these actually come with a very impressive warranty, at 70,000 miles for P-metric or passenger vehicles, and 60,000 miles for LT or light truck applications like you see here on this Bronco. According to Hankook, this warranty is second to none for the segment, and the simple reason for the mileage discrepancy between passenger and light truck is that LT tires tend to be used on heavier vehicles, which correlates with more wear. And okay, using LT as an example, how do they land on 60,000 miles for the warranty? Well, in this case, testing is conducted by a third party, where they take a 3/4 ton pickup truck, think 250 or 2500 series trucks, and they put it through a real-world mileage accumulation test that includes both on-road and off-road driving. The proportion of on-road versus off-road driving is of course dependent on the type of tire used. So this all-terrain tire is certainly going to see more off-road use than a highway terrain tire, but less than a mud terrain tire, which is basically dedicated for off-roading. So they put 16,000 miles on the tire throughout these different real-world courses, and based on that wear they can evaluate how long the tread will last. And you end up with the warranty numbers which they're confident they'll hit. Okay, so a huge part of tread life is having sufficient tread depth. But there are significant compromises you make when you have a high tread depth. So let's talk through 5 major challenges: weight, tread chunking and rigidity, noise, steering response, and rolling resistance. Alright, number 1, weight. And this is basically unavoidable, right? As you increase tread depth, you're adding material. More material equals more weight. And this weight is at the outside of the tire, so it has a big impact on the tire's moment of inertia, basically its resistance to moving. The bigger the tire and the more mass you put at the outside of that tire, the more difficult it is to accelerate that tire. So the added weight plus the location of that weight means worse fuel economy and worse acceleration. But these are generally accepted sacrifices that come with vehicles in this territory. Okay, number 2, we have tread chunking and tread rigidity. And really it's 2 separate issues, but they're very correlated. So if you imagine a racing slick with no tread blocks, just a smooth surface, that's a very strong structure because it's all connected. Now if you do the opposite, say you have long skinny spikes of rubber sticking out, well, these rubber spikes aren't going to perform well off-road. They're just going to get ripped off the tire. So basically, you're finding a happy medium between these 2 extremes with an all-terrain tire. You want the tread blocks to be able to dig into sand and mud and dirt, but if you make them too tall, they lose rigidity and they're more likely to shear and chunk off. But you've got a few defenses here. Of course, a major one being a hard, rigid compound, as I mentioned earlier. Also, the larger and wider you create these blocks, the more rigidity they have, so you'll notice the tread blocks are quite large. And finally, you can have tie bars, which you can see here on the outside of the tire, which connects the outer tread blocks. This reinforces the bending rigidity and helps it to prevent chunking. Moving on to number 3, steering response. Alright, so as we just discussed, as you increase tread depth, meaning taller tread blocks, you increase tread movement. So if you have squirmy tread blocks, your steering response suffers as a result. You have more movement happening, so it's never going to respond like a summer tire. But everything we mentioned regarding tread chunking and tread rigidity is at play here to minimize the loss of steering response. The story is similar with your sidewalls, so tall sidewalls can hurt your steering response, but by making them stiff, you minimize the consequences. Challenge number 4 is noise. Okay, and this is basically unavoidable. All-terrain tires are simply going to be louder than typical all-season or summer tires. Now, tire noise is an extremely complex subject, but one of the major reasons why these styles of tires are louder is because of the increased tread depth. So as the tire rotates, it squishes into the ground, and this squeezes and compresses this tire, pushing air out from these grooves, and then as it releases from the ground, it then pulls that air back into these grooves. And this air pumping is constantly happening, so you're constantly generating this noise. As you increase the tread depth, you're increasing how much space or how much volume you have in these channels, thus increasing this air pumping effect, thus increasing noise. Also, since you have the tread coming up onto the sidewalls, this can disrupt the airflow on the outside of the tire, which also impacts noise. So no matter what, it's a challenge, but there are ways that you can minimize tire noise. First, you have staged block edges. So you can see in different locations, you have this part of the tread block that's a bit lower and goes into the groove. And the idea here is very simple. You're filling in the grooves more, so you have less volume overall. The same idea goes for your land to sea ratio, where you have tread and where you have gaps. From a noise standpoint, you want to maximize the amount of land you have to minimize air pumping, but of course, you're fighting against having those voids for other purposes. And the shape and direction of these grooves, the main channels as well as the lateral grooves, is very intentional to optimize for noise. Now, the movement of these tread blocks also creates noise. So again, a rigid compound is helpful here, as are the tie bars on the outer tread blocks. So these tie bars help reduce how much movement you have with these outer tread blocks. Less movement, less vibration, less noise. And one last comment about noise. The pattern of these tread blocks is very important. As they continuously slam into the ground as the tire rotates, this rhythmic nature generates a vibration, and thus noise. But you can improve this characteristic by breaking up the pattern. So as you can see, they use what appears to be very random tread block widths. So you've got a really large one here, a really small one here, and different variations. And this is very intentional. It breaks up that sequence. This is called multi-pitch sequencing, and it's done to reduce tire noise. Finally, we get to number 5, rolling resistance. And again, this is unavoidable. If you have more tread depth, you have more movement of your tread blocks, which generates heat. On top of this, you have a heavy tire with a large surface contact area, and all of this negatively impacts fuel economy. Now, yes, these tires are generally used on vehicles where you know fuel economy isn't the top priority, but it's still an important characteristic for modern fuel economy standards. Saving money at the pump and better efficiency means you have more power. So again, we go back to a rigid compound as well as rigid sidewalls, which are both important for reducing rolling resistance, but the real reasons for that rigidity is dictated by the driving scenarios and types of vehicles these tires are used on. Additionally, as this is a 3-peak Mountain Snowflake rated tire, the tire has sipes for better snow performance. You'll notice the zigzag nature of the sipes, improving rigidity, which also minimizes the impact on rolling resistance, and they're also at different orientations to optimize grip in any direction. Okay, a few more unique features that are worth pointing out. You'll notice a highway tire has straight grooves running down the tire for wet traction. On this all-terrain, the grooves are zigzagged. Hankook says this is done to minimize damage to the tire when off-road, and also that it helps to shed mud and stones. So the straight open grooves like you have on this highway terrain tire, they're really not doing much for you in the mud, right? It's simply just going to slide right through that straight groove. Versus if you have a zigzag pattern, well, now that acts like a shovel or a scoop pushing against that mud as it squeezes into the grooves. Also, you'll notice the tread of the tire continues onto the tire's shoulders and partially up the sidewalls. So this is really helpful in loose surface scenarios. When you're in sand or mud or dirt, these shoulders can shovel away at the environment, letting you drive in deeper sand and mud. They can also help in rock crawling scenarios where the side of the tire is wedged against a rock, providing additional grip. And not only do you improve off-road traction, but you also better protect your sidewalls from damage or punctures. So big picture, we've got a stiff, all-season-like tread compound with traction in all 4 seasons, a durable carcass, and a deep, wide tread to handle every off-road scenario while still offering a really long tread life, and all of which is optimized to allow for a very roadworthy tire. This is no small feat. I hope you've enjoyed this. I think we constantly take for granted just how incredibly complex and, in my opinion, how incredibly cool tires are. So a big thank you to Hankook for sponsoring this video and getting me access to engineering to learn all about them. I'm happy to say there are more videos like this on the way. If you have any questions or comments, feel free to leave them below. Thanks for watching.